world record holder for most penalty kicks made in a season. We have the one, the only dollar bill.
The past is the past, you know? It's a new day, bro. My day.
Nice to meet you, Dollar Bill. So show us how you're so good at these penalty kicks and why you're known for it.
Well, it's basically the kick and the physics behind it. Let me show you how it's done.
Okay. Ball moves in the air after money-making Dollar Bill kicks it. This is due to the Magnus effect. In this case, Magnus effect is used as a spinning ball curves away from its principal flight of path. When money-making Dollar Bill kicks the ball into the air, the ball undergoes top spin. This causes the velocity around the air velocity around the top half of the ball to become less than the air velocity around the bottom half of the ball. Similar to this description, we have the soccer ball traveling clockwise, and we have air going against the ball as it's traveling down the air, and we have a force that's downward. Since the airspeed on the top half is less than the bottom half, the pressure is greater on top of the ball. This causes the force to be downward. When someone kicks the ball, for example, right of the center, then the ball travels left, as you can see in these two pictures.
I'm going to show you how to calculate the Magnus force. Here's the equation for Magnus force. Fm equals 1 over 2 CD, which is coefficient of drag, rho, which is density of air, times the surface area and the velocity of the ball squared. Now in this case, the coefficient of drag is constant. It is 0.5, and so as the density of air, it is 1 over 2 kilogram over meter cubed. Now let's calculate the surface area of the soccer ball. The equation for the surface area is A equals 4 pi r squared. Now based on our calculation, the radius of the soccer ball is 0.11 meters. Let's plug it in. Surface area equals 4 pi times 0.11 squared, which gives us 0.15 meters squared. The speed of the soccer ball was 33 miles per hour, which can convert it into 15 meters per second. All the variables, we can plug in to solve out the force of Magnus. So the force of Magnus will be Fm equals 1 over 2 times 0.5 times 1.2 kilograms per meter cubed times 0.5 meters squared times 15 meters per second. And now that will give us 10.1 newtons. And that's what the force lifts the ball up and makes it. Explain everything with a free body diagram. Here's a soccer ball. The direction is going this way, and the force of gravity is keeping it down. The force of drag is the opposite way of the velocity, which is similar to the air resistance. Now the force of Magnus is what the force that keeps the ball up, so it will be right here. And these two forces are the forces to make the ball spin, which cause the ball to curve.
Special guest. He is 6-time league MVP.
What?
Reigning three-point champion.
What?
And current record holder for the most threes made in a season. We have John.
I want to be the best in this way. That's why I play the game. To be the best, you have to win. And that's what drives me.
He's the best player in the game. It's just that simple. There's nothing that Kobe Bryant can't do. He will defend your best player. He will shoot from the perimeter. He will get all in your mug. He will do whatever it takes. He is the most complete basketball player.
Thanks for having me, Jalen. I'm glad to be here.
Okay, so tell us, what do you need for you to be a perfect three-point shooter like yourself?
Well, I mean, good form is key. Feed part, get your base. But another secret, don't tell anybody, that I like to use is backspin.
Okay, so if you all don't know, the backspin keeps the ball on the vertical parabola path so that you have a greater chance of it going in. Without this parabola path, you have a lesser chance of making it inside the rim.
You want to show them how it works, Jalen?
Sure, let's go. We need two equations. first equation is moment of inertia of a hollow sphere. The second equation is angular speed. The equation for angular speed is omega equals 2 pi over t. Now t is the period, so the revolutions that the ball will travel in 1 second. Angular velocity, also known as angular frequency, is a scale or measure of the rotational rate of the basketball. And moment of inertia, inertia is the resistance of any physical object to change its state of motion.
Hello, Sports Fabulous. John Jordan here. Although I'm a 6-time MVP, I'm also a 2-time valedictorian who graduated from Harvard. Today, I'm going to show you guys why I use backspin. Backspin helps create inertia. To calculate this inertia, we have to go through a series of steps. First, we have to find the mass. After we do that, we have to find the circumference. When we find the circumference, we then can solve for r. Once we have that, we can finally solve for inertia. So first, let's calculate the mass. To do this, we need a simple Newtonian equation. F equals ma. To find m, we have to divide the acceleration by the force. To help me, I'm going to use a spring scale. As you can see, the force is somewhere between 6 and 6.1. We're just going to say 6. Force, which is equal to 6 newtons. And we also know that the acceleration due to gravity is 9.8 meters per second squared. We can now calculate the mass. F over A, 6 newtons divided by 9.8 meters per second squared. Let me think, that is 0.61 kilograms. We now have the mass. So now that we have that, we can find the circumference. If I look at this, the tape is somewhere right here. So I'll now take that off, measure the distance from here using a meter. You can see the circumference of the ball is 29.5 inches. Get a good look. The equation for circumference is C equals 2 pi r. We already found the circumference of the basketball earlier, which is 29.5 inches. To calculate the radius, we have to divide 29.5 inches by 2 pi. 29.5 divided by 6.28 equals 4.69 inches. Now that we have our r, our radius, and our mass, we can now find the inertia. We have our mass and our radius, we can find inertia. The equation for inertia, I equals 2/3 m over r squared. We can now plug in the mass. And we can also plug in the radius. We had to convert the inches to meters, so, which is 0.11 meters. Using my super mathematical skills, we calculate that I equals 0.04 kilograms times meters squared. This is the resistance that I have to overcome to get my shot off. And you might be wondering why this helps. Well, inertia is important. When I use backspin, inertia ensures me that a player, if they try to block my shot, they'll have to hit harder than this resistance if they want to change the direction of the ball. Find our inertia, which is equal to 0.04 kilograms times meters squared. To calculate the angular momentum, we have to find the angular velocity. The equation for angular velocity is omega equals 2 pi over t. T being the number of revolutions it travels in a certain period of time. The equation for t equals little t over revolutions. Lowercase t was equal to 1.41 seconds, and the revolution was equal to 3 cycles. when we calculate for capital T, we can find that it was 0.47. This was the number of seconds it took for it to complete one revolution. Now that we've calculated capital T, we can now find the angular velocity. Omega equals 6.28 over 0.47. Using my mathematical brain, we can find that omega is equal to 14.7 radians per second. This is omega. Now that we've found omega, we can calculate angular momentum. This is the formula for angular momentum. AM equals inertia times angular speed. Now from here it's just a simple plug and chug. 0.04 kilograms meters squared times 14.7 radians per second. Using my mathematical brain, we can find that angular momentum is equal to 0.536 kilograms per meter squared over seconds. This is how we find the angular momentum. Why you would use angular momentum is because it allows the ball to stay in a parabolic motion when going on its way up. This increases your chance of making the basket. This is why I use backspin.
This concludes today's episode. I'm your host, Dr. Jay Phipps, and we hope to see you all next episode on Sports Fabulous.
Sports Fabulous. To find the mass, I'm first going to use a simple Newtonian equation. Sum of the forces equals ma. Now, as you see, I've tied a string taped to a ball. What I'm going to do is use a spring scale. A little bit of a struggle. It's for you, Mr. Willard. Hey, Jalen.
I know you're a 6-time MVP and everything, but I got a little bit game too. You trying to go one-on-one real quick?
Let's do it.
All right, let's go.
Time MVP, Jalen. I heard there's a Mr. Willard out there. Challenge me! I dare you. Bring that in my house. Forget that shot, Mr. Willard. 6 times.